This code installs a specific version 0.0.53 of the Python library Sacramoses using pip. Sacramoses is a library that is used for data processing and tokenization for language models and natural language processing tasks. By installing this specific version, the code ensures compatibility with the rest of the code and dependencies in the LLMs with Hugging Face project. This Python code imports the necessary modules and libraries for working with language model LLM using the Hugging Face framework. It also sets up the classroom environment by defining a class with necessary helper functions, such as downloading datasets and initializing the Hugging Face model. This code makes it easier for learners to set up their environment and get started with working on LLMs using the Hugging Face framework. It also allows for easy access to the solutions for exercises and challenges. Through this code, the load dataset function from the datasets library is imported, which is used to load various datasets for natural language processing tasks. Then, the pipeline function from the transformers library is imported, which is used to create a standardized workflow for processing text input with pre-trained language models. This code loads the XSum dataset using a predefined function from Hugging Face. The dataset version 1.2.0 is specifically chosen, and the cache directory is specified to use pre-downloaded data instead of downloading it again. The loaded dataset object is then printed, showing the number of rows in each dataset split. This code snippet retrieves a sample of the XSum dataset, specifically the training subset, and selects a range of 10 data points. It then uses a function called display to convert the selected data into a pandas data frame and displays it. This allows for easy viewing and analysis of the data. This code sets up a pipeline for text summarization using the T5 small model from Hugging Face. The min length and max length parameters define the minimum and maximum length of the generated summaries, while truncation equals true indicates that the input text should be truncated to fit within the specified lengths. The model quargs parameter is used to specify the cache directory where pre-downloaded models will be stored. This allows for faster access to the model instead of downloading it every time the code is run. This code uses the Hugging Face library, specifically the LLM's language model-based models, to summarize an article. It retrieves an article from the XSum sample dataset, specifically the document column of the first entry in the dataset 0. It then applies a summarization model to this article and produces a summarized version. This code uses the summarizer function from the LLM's Hugging Face library to generate summaries for a batch of articles stored in the XSum sample variable. The results of the summarization are then stored in the results variable. This snippet assumes that the XSum sample variable contains a document in a format that the summarizer function can process. This code snippet imports the pandas library and displays the generated summary side by side with the reference summary and original document. It uses the pandas library to join the generated summary text and the reference summary and original document together, and then displays them in a nice format using the display function. This code snippet loads a dataset called poem sentiment with a specific version number from the cache directory and stores it in a variable called poem dataset. Then it selects a specific range of data, 10 items from the train subset of the dataset, and stores it in a variable called poem sample. Finally, it displays the data in a human-readable format using the toPandas function. It is most likely used for training or analyzing language models and sentiment analysis on poems, where this code creates a sentiment classifier using a pre-trained natural language processing NLP model called Nikwang64 BERT-base uncased poems sentiment. This model is loaded from the specified cache directory. The sentiment classifier is capable of performing the task of text classification, which involves predicting the sentiment positive, negative, or neutral of a given text input. This classifier is created using a tool called Hugging Face, which facilitates the use of pre-trained NLP models without requiring extensive coding knowledge. This particular code snippet first selects the verse text data from the poem sample variable and then passes it into the sentiment classifier function. This function is likely a language model from the Hugging Face library that is specifically designed to classify the sentiment positive, negative, neutral of a given input text. The function then returns the results of the sentiment analysis, which could be in the form of a numerical score or a label indicating the sentiment of the input poem. This code snippet is part of the evaluation process of a language model LLM created using Hugging Face. It first creates a data frame using the predictions from the LLM, renaming the label column to predicted label. Next, it joins this data frame with another data frame created from a sample of text, renaming the label column to true label. This creates a new data frame with the predicted sentiment positive, negative, no impact, or mixed side by side with the actual sentiment label from the sample text. Then, it changes the label indices 0, 1, 2, 3 to their corresponding text labels using a dictionary. This is done for better readability and understanding of the results. Finally, the joined data frame is displayed, showing the predicted sentiment, true sentiment, model's confidence score, and the original text in each row. This allows for easy comparison and evaluation of the LLM's performance. This code creates a variable named EN to ES translation pipeline and assigns the value of a pipeline object to it. The pipeline object is created using the Hugging Face framework and is set to perform a translation task. The specific translation model used is Helsinki NLP Opus MT-ES, which translates text from English to Spanish. The model has been given the keyword arguments cache_dir with the value d.paths datasets. These keyword arguments are passed to the model during its initialization. This code runs a translation pipeline that uses a pre-trained model from Hugging Face to translate a piece of English text. Existing, open source, and proprietary models can be used out of the box for many applications to Spanish. The resulting translation is not shown in the code snippet. This code snippet creates a pipeline for language generation using the T5 small model from the Hugging Face library. The pipeline is set up to perform the specific task of text-to-text generation, which means it can take in a piece of text and generate an output text based on the input. The maximum length of the generated text is set to 50 tokens. It also specifies the location of the cache directory for the dataset used in the model. This code is used in LLM's language learning models with Hugging Face to facilitate language generation tasks. This code uses a small pre-trained T5 model from Hugging Face to create a pipeline that takes in a string of English text, uses machine learning to translate it to French, and returns the translated string. The specific text being translated is existing. Open source and proprietary models can be used out of the box for many applications. This code snippet uses the T5 small model from Hugging Face's library to create a pipeline for translating English to Romanian. It then takes in a string as input and translates it to Romanian using the model. The string provided is existing, open source, and proprietary models can be used out of the box for many applications. The first line of the code initializes a zero-shot classification pipeline with a cross-encoder model NLI Deberta v3 small from the Hugging Face library. The model is set to use a specific cache directory for storing datasets. The next section defines a helper function called categorize article. This function takes an article as input and uses the zero-shot pipeline to predict its category. The function also specifies a list of candidate labels that the model can choose from. Then, the function runs the input article through the zero-shot pipeline and stores the results in a variable called results. It also removes the original article from the results and displays the remaining categories and their confidence scores in a neat table format. This code allows users to quickly categorize articles without the need for fine-tuning the model for specific labels. The model can use its general training to make educated predictions about the most relevant category for the given article. This code snippet is part of a larger Python code that categorizes articles using a pre-trained long short-term memory LLM model from the Hugging Face library. The function being called, categorize article, takes one parameter, an article in the form of a string. The string provided in this specific example appears to be an article about a rugby game between the Glasgow Warriors and the Dragons. The article contains a summary of the game, including the players involved and the final score. The purpose of the code is to use the LLM model to analyze the article and assign it to a category based on its overall content. The LLM model uses machine learning techniques to analyze the language used in the article and determine its category. This can be useful for organizing and sorting articles based on their content, as well as for understanding patterns and trends in news or online content. This code snippet defines a function called categorize article that takes in a long string of text, which is presumably an article about flooding in Scotland. The function does not return anything, so it likely performs some kind of analysis or categorization of the article. The purpose of this function is likely to aid in the processing and classification of articles for a larger natural language processing project or tool. It could potentially be used to classify articles by topic or sentiment, or to extract specific information from the article. This code snippet creates a few-shot pipeline using the pipeline function from the Hugging Face library. The pipeline is used for text generation tasks and specifically uses the GPT-Neo 1.3b model from Eleuther AI. The max new tokens parameter limits the length of the generated response to be no more than 10 tokens. The model kquargs parameter sets the directory where the model's datasets will be cached. This code is part of a few-shot learning pipeline using Hugging Face for language model pre-training. It gets the token ID for the special string text step, which likely represents the end of a sentence or document, and assigns that token ID to the variable EOS token ID. This token ID will likely be used as a special marker to signify the end of a given text sequence. This snippet is important for setting up the few-shot learning pipeline with Hugging Face, as the HAG token is a key component for the EOS end-of-sequence token. This code uses a pre-trained model from Hugging Face to generate a sentiment analysis result on a given tweet. The few-shot pipeline function is likely using a pre-trained model trained on a few-shot learning task, meaning it can solve tasks with limited training data. the results variable is assigned to the output of the function. The generated text from the first result in the list is then printed, which is likely the sentiment analysis result for the tweet. This new music video was incredible. This code snippet is part of a language model using Hugging Face, which provides a few-shot learning pipeline. This pipeline utilizes only a few examples to fine-tune the model for a specific task. The few-shot pipeline function takes in the input text, in this case, 2 tweets, and descriptions of their respective sentiments. The code snippet then uses the model to generate a new text based on the input and the trained model. In this example, the code will generate a text description for the sentiment of the second tweet. The generated text is then printed and can be used for further analysis or evaluation of the model's performance. This process can be repeated for multiple examples to improve the model's accuracy. The code snippet is using a few-shot learning pipeline to train a language model on sentiment analysis. It provides 4 different example tweets with corresponding sentiments, negative, positive, neutral, and positive, and then generates the sentiment for the provided tweets using the model. The generated sentiment is then printed to the console. Example output, negative. This code uses Hugging Face's few-shot pipeline function to generate a list of suggested drink pairings for different types of foods. It prompts the function with different food and drink combinations, using a special token EOS token ID to indicate the end of each input. The generated text that the function outputs is then printed to show the suggested drink pairing for the first food listed tapas. This model is likely using a pre-trained language model to generate these suggestions based on a large corpus of text. This code snippet uses the LLM's language models provided by the Hugging Face library to generate a description of a person based on a given emotion. The few-shot pipeline function takes in a string of text with specific formatting, which includes the emotion word and possible descriptions. It then uses a pre-trained language model to generate a description for that emotion. The generated description is then printed out. This process may not always work perfectly, and the results may vary depending on the input. This code generates book summaries using a language model. The few-shot pipeline function takes in a string of text which contains book titles and descriptions and uses these as prompts to generate a book summary using the Hugging Face language model. The code also overrides the default setting for maximum number of new tokens generated to ensure that longer answers are generated. Overall, the code snippet allows for automated generation of book summaries for a variety of different books. This code snippet uses the Hugging Face library to display a summary XSum sample as a pandas data frame. This means that the summary is presented in a structured table format that can be easily viewed and manipulated. The toPandas function converts the summary into a pandas data frame so that it can be displayed in this manner. This code calls the summarization pipeline from Hugging Face's language model LLM library, which allows for the generation of summaries from input text. The input text is fetched from the first document in a dataset called XSum sample. The default inference configuration is used, which refers to the settings and parameters that are used during the inference process or the generation of summaries. In this case, the code uses a method called greedy search, which is a process for generating text that involves selecting the next token with the highest probability in each step. The summarizer function then takes the first document as input and generates a summary from it. This code snippet uses the Hugging Face library to perform text summarization on a document from the dataset XSum sample. The function summarizer is used and an additional parameter numBeams is specified with a value of 10. This changes the default behavior of the summarizer from a greedy search to a beam search, which may result in a better summary but will take longer to run. This Python code uses the Hugging Face LLM's language model library to perform text summarization. It takes in a document and uses the XSum extended single-sentence summarization dataset to summarize the document. The code first takes the first document in the XSum dataset and passes it to the summarizer function. The doSample parameter is set to true, which enables sampling when generating the summary. This means that the model will randomly select words when generating the summary, instead of always choosing the most probable words. This code uses Hugging Face's LLM's language model to generate summaries for texts from the XSum dataset. The function summarizer takes in 2 arguments, the text to be summarized and a Boolean for whether or not to use sampling. In this case, sampling is set to true. The 2 parameters top_k and top_p are used to tweak the sampling method. Setting top_k to 10 limits the number of possible next tokens to choose from to the top 10 most likely options. This makes sampling slightly more conservative and less random by only considering a small set of very likely next tokens. Similarly, setting top_p to 0.8 means sampling will only consider tokens that make up the top 80% of the probability distribution for the next token. This also makes sampling more conservative and reduces the chance of selecting a random or unlikely token. Overall, By using these parameter modifications, the code is attempting to generate summaries that are more focused and pertinent to the input text. This code imports the necessary libraries and modules for using LLMs with Hugging Face, specifically the auto tokenizer and auto model for seek-LM. The tokenizer and model are then loaded from the pre-trained T5 small model with the cache directory set to a variable called da.paths.datasets. This allows the code to access the necessary pre-trained data for the T5 small model. This code creates a list of prompts for summarizing articles using the T5 small model from Hugging Face. It takes in a set of articles, xsum sample document, and uses the map function to add summarize to the beginning of each article. This creates a list of prompts that can be used with the T5 small model to summarize the articles. Finally, the code displays a data frame with the list of prompts under the prompts column. This code snippet is part of LLM's language model models with Hugging Face, which is a popular natural language processing library in Python. The first line, tokenize the input, means that the code is splitting the text input, presumably some articles, into individual tokens, which are usually words or characters. The next line initializes a variable called inputs and assigns it the result of using the tokenizer function on the articles. This function takes in the articles as input and also specifies some parameters, such as the maximum length of the token sequence, 1024 in this case, returning the result in PyTorch format and adding padding and truncation if needed. The third line prints out the input IDs, which are the numerical representation of the tokens. This is useful because LLMs require the input to be in numerical form. The fourth line prints out the attention mask, which indicates which tokens are important for the model to pay attention to and which ones can be ignored. Overall, this code snippet performs the necessary pre-processing steps needed to prepare the input data for use in LLMs with Hugging Face. This code uses a pre-trained language model from Hugging Face to generate summaries based on given inputs. It takes in the input IDs and attention mask from the inputs and uses numbeams equals 2 to generate multiple possible summaries. The min length and max length parameters control the length of the generated summaries. The model.generate function then generates the summaries and prints them as summary IDs. This code takes generated summaries represented by summary IDs and decodes them using the specified tokenizer, likely a tokenizer from Hugging Face. The result is a list of decoded summaries without any special tokens, such as S or S. Finally, the result is displayed in a pandas data frame with a column titled Decoded Summaries. This may be useful for reviewing and evaluating the generated summaries. This code imports the T5 tokenizer and T5 for conditional generation classes from the transformers library. It then creates an instance of the T5 tokenizer class using the T5 small model, which is the T5 transformer model trained on a small dataset. The cache_dir argument specifies the directory where the model is cached. Next, the code creates an instance of the T5 for conditional generation class using the same T5 small model. This class is used for language generation tasks, where the model is conditioned on a given input and generates an output based on that input. The cache_dir argument is again used to specify the directory where the model is cached. Overall, this code snippet is used to initialize and load the T5 transformer model for use in natural language processing tasks. This code snippet is used to process a list of articles using a pre-trained tokenizer and model from the Hugging Face library. The tokenizer is used to tokenize the articles and create input tensors for the model. The model then generates summary IDs using the input IDs and attention mask provided by the tokenizer. The number of summary beams, minimum and maximum length of the summaries can be specified. The summary IDs are then decoded using the tokenizer and are added to a data frame for display. Overall, this code is used to generate summaries for a list of articles using pre-trained language models.